Okay, so thank you very much for having me. So I'm going to be your host today. So let me just bring up the slides and exit this one. Okay, so before we start, how many of you have been, so this is session number 2. We were lucky enough to do one before this in September. Have you been to the previous one? Raise your hand. One hand here. One at the back. That's it. Okay, that's really good. So what we're going to do today, we're going to have a look at this Kubernetes thing, okay? And how does it work? You know, how do we play with it? So that's the goal of today. So most of the time you will get stuck. Okay, so you will need to call myself, and my name is quite complicated. So first thing, let's sort this out. You can call me any of these names, okay? And I will come to you and I will help you out. So you can call me Daniele, Dan, Daniel, but please, please, please do not call me Danielle, okay, with the French name. That's the only rule for the workshop. Okay, so who am I? I've got a Kubernetes certification, so I think I've got some credentials to teach Kubernetes, and I was lucky enough to speak at KubeCon, which is the Kubernetes conference, twice in Shanghai, and it was a very, very nice experience. So, but we're not here to talk about me and what I do. No one cares. We're here to talk about Kubernetes and how we're going to use it, right? So the goal of this session, right, this 3 hours workshop that we're going to do, is to learn how we can build applications. So if you are a developer or someone who's interested in just deploying application, first of all, we need to understand, you know, what do we need to use? How do we need to change our code? Is there anything we need to change when we deploy to Kubernetes, right? So that's the first thing we're going to do. Then the second one is going to be, Kubernetes comes with some rather unusual terms, right? We don't call things with their names. Too easy. We don't call load balancer, we call it service, right? We're going to learn how to speak the Kubernetes jargon. And then the third one, I think this is quite ambitious, but the material that we have today goes also into deploying locally and then deploying into the cloud as well, into AWS or Google Cloud. I think it's going to be a little bit ambitious to cover that as well, but the material, it covers that, and you can practice in deploying into the cloud as well. So what we're going to do today, right? We've got 3 hours. We start a little bit late, so maybe it's not going to finish at 5. We're going to finish a little bit later than that. But the plan is like this. So we're going to build an application, first of all, right? So we need to deploy something into this cluster. So we're going to build our own application, and then we're going to package it as a container so that Kubernetes doesn't understand applications like Java or Node.js. The only things it understands is containers. So we're going to have a look at containers. And then I've got part 2 twice. Okay, that's a mistake. This should be part 3. We're going to have a look at how we deploy that into Kubernetes. Okay, and we have a look at what kind of things we need to do. Now, there are more parts that we're not going to do today, but you can do it when you go back home, right? So you can take the material with you and practice when you go back home. And those parts are basically scaling and having state and deploying into the cloud. That's unlikely we're going to be able to cover that today. Okay, and then I hope you have time, but if you complete the last challenge, you also get a certificate of completion for today, okay, which I think is quite nice as well. So, how does it work? So I don't think you want to listen to me talking all the time, and you want to get your hands dirty, right? So we're going to have a little bit of me explaining what we're going to do, and then you're going to do it, right? And it's going to be myself and the rest of the people in the back just helping you out, making sure that you get these applications deployed into Kubernetes. I've got a very ambitious agenda, and we're already late. Okay, so we're probably not going to finish at 5 because we start a little bit later than that. But the plan is to finish in 3 hours anyway. Okay, so Kubernetes is a little bit tricky. So sometimes you might notice that your Minikube doesn't work, or you don't have the right version of Docker, or something else. Now, we're going to help you out, but sometimes you're going to get stuck. And instead of just being stuck and fixing your problem, it makes sense if you pair, with the person next to you, okay? And you just get it through. We're still going to help you and fix everything, but just, I think you should follow the rest of the material as well. We've got Slack, so if one usually get lost, they can connect to Slack and they can send me the links and I can fix it. But other than that, I think it's not absolutely necessary. So that is the plan. Before I start, is there any question? How many of you are stuck installing Docker or Minikube or kubectl? Raise your hand. I can see, okay, well, we are sorting that out. We are working on it. Anyone else? Okay, don't worry if yes, I'm going to help you out. Don't worry if this is broken, just raise your hand. We will help you out, okay? So this is the second time we run the workshop. Okay, so please be nice. We haven't found the perfect way to teach this Kubernetes in just 3 hours. We usually run 3 days workshops, okay? So 3 hours is a lot less. So we're trying to do our best to make it work. Okay, is there any questions? Are you ready to start? I don't see you excited. Are you ready to start? Yeah. Oh, there we go. Okay, let me grab the slides. Okay, so what we're going to do today, we are going to build an application. Okay, first of all, we need an application to deploy into Kubernetes, and this application looks like this. Okay, it's called Knode, and what it does is a simple, very simple note-taking application. Okay, so you can write some content, you can click on publish, done. Okay, just going to save some notes. We're going to add something else into the mix just to make it a little bit more complicated. And what you can do, you can also add a file. Okay, it's going to upload the image and it's going to insert that image into the text area. Okay, please notice what kind of gibberish is there. This is Markdown. Okay, I don't know if you're familiar with Markdown, but it's just basically plain text with some extra markup. So when we save that, we click on publish, we also get the image as well as the text, right? So this is a little bit more complicated than just saving text. We're also saving images, right? Which is going to give us the opportunity to explore other areas as well. So the application that we need to build, we have a couple of requirements. So we need an application, right? Something to serve these pages, okay? We need a database. We talked about files, so we need also to store these files somewhere, okay? So if I think about it, then I definitely need something like either Node.js or Java just to serve the application. Then I need a database. I pick Mongo because I don't need to define a scheme or anything like that. So it's a little bit easier to get going. And I need to connect those two together. So the plan is to use just static pages. So if you are a React fan, I'm sorry, I'm going to disappoint you today. We're going to upload files and all the rest. So this is a very simple application, okay? So you won't be able to deploy this to production, have multiple users and so on and so forth. But maybe, if you want to go back and refactoring and add whatever you want, that's a good opportunity. Okay, so that is the plan. And we're not going to use Postgres because it's a little bit more complicated. So we're going to build this application first, okay? I wanted to build it locally. And this is what you're going to do. You're going to create it, connect it to MongoDB, and then test it locally. I want to see you uploading images, you uploading text, and just seeing the application locally. Why? Because first, we build it locally, then we package it as a container, then we put it inside Kubernetes. Okay, so this is the first step. So the way we do it, I know that you might miss some of the steps. We've got also a GitHub repo, but we've got this URL, so you should sign up to this website, which is called academy.learnkubernetes.io. You go inside, there is a page which says sign in. Just enter your email address, click on sign in, and then you get an email back. Just click on the link, and then you're logged in. Okay. So everything we do is going to be from the Academy, so you can follow along. Okay, and you can click on Start, and then it's the first module. Now, how many of you here are doing the Java version? I can see a couple of hands. So last time we didn't have anyone. Okay, so I'm really glad that even we have people with background in Java. So if you are in Node.js, just click on the Node.js version. Otherwise, click on the Java version. And then the first part is actually describing how to write this application. Now, last time, so what I want you to do is to go and do it. But before you go and do it, I want to show you what the end result should look like. Okay, so you're going to clone a repository, right? Either download or clone a repository. What kind of repository you need? So we have two repositories. I'm going to show you the Java version, the JavaScript version, but the Java version is the same. So we have a learn.sk Node.js or Java. And this repository is what we're going to use today. It's got 5 different chapters. We're going to do the first 3 chapters, okay? So you're going to download this, either clone or download it. And then you're going to have it locally, like myself here. So I can, it's quite busy. So then we're going to do part 1. So you're going to do to cd01. And you're going to install all the packages with npm install, or if you're using Java, you do a maven install. You're going to install all the packages, and then I want you to start the application with, let me just, how do I make it? No. Woo. Okay, that is not going to work. Okay. So what I want you to do is to start the application. So the application is failing, right? Because there is no database. So what you will need to do is to just start the database as well. Okay, so once you do that, the application is available. We click on the application, okay, and then it's running. Then I want you to try that it actually works. So is this okay? Yes. You upload it, and then hello. Yeah, I will do that. Yeah, you can publish it and then check that it actually works. Okay, so that's the end goal. Now I'm going to go back to the slides. So this is the plan. You go on this URL, you look at the first page, and then you will find the steps to actually download this and then run your own application. Okay? So that is the plan. We have half an hour to do that. So it's going to be like very, very quick. And then after that, we're going to start with Docker. So you don't need to complete this part to enjoy the second one, but I think it's still relevant, it's still better if you do, okay? So myself and the others are going to be around and help you out, but the plan is launch the app, upload an image, add a node to your Node app, okay? So some of you managed to get the application up and running. They uploaded, they had a node, and they uploaded a picture of a cat. If you did that, well done to you. If you haven't, don't worry, we're going to try again. But this time we're going to do it with Docker. Okay, so I'm going to start the next part, and we're going to talk about Linux containers and Docker. So I suggest that if you are stuck or someone is helping you, we pause for a second, we do the lecture, then we go back. Okay, you can decide to go back and do the previous session, or you can do the next one as well. It's up to you. Okay. Okay, so let's have a look. So generally, you are at work, and this is the kind of discussions you have with your colleagues. I built a Node.js app, right? It's great, and someone comes to you, or a Java app, right? Someone comes to you and say, okay, can I have it as a zip file? And you say, of course you can. Here you go. There is a JavaScript file, some images. I'm going to give it to you as a zip file, and done. The person goes off, they run, and it doesn't work. It's rubbish. Why? Oh, because we don't have the right version. It's missing stuff. I had stuff installed in my laptop. It doesn't work. But it kind of does work, right? Yeah, it does work on my machine. But what about someone else, right? So this kind of problem, they tend to be quite common when you have things like libraries, right, which are dependent on your operating system. So you might be familiar with a technology called Puppeteer or Phantom.js, which are basically like browsers that you install locally, and then you can do things like Selenium, or you can do a bunch of different things. And then these kind of binaries, they tend to be compiled for an operating system. So if I have a Windows machine and you have a Mac, right, how do we share the same file, which doesn't work? So I cannot just simply zip something and give it to you. It's never going to work. And then if you are in a sort of JavaScript community, it's even worse, because we've got things like Sass, for example. And not only there are different versions for different operating systems, but there are several different versions for also the Node.js that you're using, right? So it might work with version up to 11, and then it fails with 12. And it's very, very annoying. What if we could have something, right, like the zip we had before, where we just grab everything together and we package it. But this time, all of the dependencies, right, even the dependencies like Sass or Puppeteer are packaged as part of a zip. So basically, this zip file, this archive is self-sustainable, right? There is no other dependency on operating system or anything else. So we call these sort of packages Docker containers, or just containers in general, okay? So Docker is the technology that popularized them, but it's not the only technology that can create containers. So, and what are these containers? Are basically just like the zip file we had at the beginning, just with some extra stuff, okay? And those are what we use to encapsulate, our files as well as dependencies to other libraries. So we talked about Docker. This is the most popular one, and that's the one you also installed locally to join this workshop. Okay, so how does this Docker work? So usually it comes in two parts. Okay, so there is a Docker CLI, so a command line tool where you type the commands. But that binary doesn't actually do the work. It's just sending the message to someone else. And that someone else is the Docker daemon. Okay, so when you say, I want to run a container, that message goes to the Docker daemon. The daemon creates the container. Okay. So what we're going to do now is we're going to package the application as a Docker container. Okay. So we're going to write this file called Docker file, which is a recipe to create the container and describe what kind of things should go inside. Okay. And then we're going to use this other command called Docker build. And Docker build, what it does is we're going to give it a name. So -t is for name. Okay. Actually, it's for tag, but pretend is name. Okay. And the other one, this is really important, right? So you see here, there is a dot. Okay, that means where this Docker file is located. And dot means the current directory. Okay, if you forget the dot, you will see an error. Okay, if you see an error, just raise your hand. We will help you out. So how do we, we build these Docker containers, but how do we run them? So for running Docker containers, we use Docker run. Okay, and then we've got an extra flag called TI. I usually like to remember these as terminal and interactive, so I can play with the terminal inside a container, okay? And then the name of the image that I want to run. So before we were building Docker build -t app, so I need to put the same name there as well. Okay, so we're going to run it, and we're going to see the application running inside a container. So we're going to do exactly what you did before, but this time we're going to run the application from within a container. Okay, so that's what we're going to do. You write a Docker file, you run this Docker file, and from a recipe, you create an image. Once you have that image locally, you need to run that Docker image and run the application again. So the result will be the same. Okay, you will see the same application with the same cat, but it will run within the container instead of running locally on your laptop. So again, all of this is in the same material as you saw before, right? So you can just go and click on Start, and then depending on which version you've got. And then the part which we are focusing right now is this one, right? The second part, where we build a container. So I want to show you what it looks like and what the end result should be. So if you're following along and you have a repo, then we're looking at version number 2. Okay, so there is a folder 02. So I can see what's inside, and I can see that there are basically the same files as before, but there is an extra file called Dockerfile. Inside this Dockerfile, there is a recipe to build what is basically a zip file, an archive. And what it's basically saying is from which image I should start. This is like an ISO. This is, if you're familiar with virtual machine, this is basically the base image, the base ISO that I want to start, the base operating system I want to start. And the second line is a little bit cryptic, but it's all it's saying is copy all the files that you see locally and put them inside a container. The third line is install all the dependencies because we need to run this application. Okay, and the fourth line is the default command when this container runs is to run the application. So when I have this, I can just do a docker build -t app dot. And this is going to go and execute these steps one by one, okay, and build this container. So it's going to take a little bit of time. It's going to download all the dependencies, and eventually it's going to create a container like here. Now with Docker, now I've got to build I built the image so I can run it. So the way I do it, I do a Docker run. Okay. Now hopefully I've got it. Yeah. I've got it prepared in advance because it's a long command. So what I do a Docker run, and then I start. This is Mongo. I start my application. So the application, you can see here there are like a lot of flags. So what are these flags? Let's have a look. So first of all, there is a P flag. The P flag basically means where should I export this port of my laptop, okay? So I can visit the application. Then there is a -E for environment, okay? So this is how we pass information inside a container about where is the database located, okay? And the other three lines are sort of a little bit more enigmatic. One is the network. I think I'll ask you to trust me on this. The other two are we remove the container when it's done, and the name of the container is Knode. Okay, so we run this. I can enter, and my application is broken. Why is it? Not running MongoDB. Well done. How do we do that? How do we run MongoDB?
So you said start.
We're going to run it as a container again. Okay, so everything you run in this session is going to be as a container. Okay, so I can type docker run. Ooh. Okay, and this command is actually going to run MongoDB as a container. So before you had MongoDB, you had either to install it or to run an extra command in Node.js to get it running. Now we actually just download it like this. And you can see that it is working. So if I go back, I can see my application now is running, right? Because there is a database where I can save all these nodes. So I can click on localhost. And I can see the application up and running. It looks the same, but this time it's running inside the Docker container. Okay? And the good thing is, if someone asks me, please can you share the application, then even if you're running on Windows and I've got a Mac, we can still see the same application. Okay? You won't get a surprise this time. Okay? So I want you to do the same. If you're running Docker Toolbox, you won't be able to get to this application through localhost okay, you will need to have here the IP address of your Docker machine. I understand that this is cryptic, so when you get to that point, raise your hand and we will help you out. Okay? So we're going to have 45 minutes now to try and run the application as a Docker container. Any question? All good. So some of you managed to get through the Docker containers. So you package the application as a Docker container, and you run it, and you saw exactly the same thing as we saw before, right? We said that the difference is that now you can grab that container and give it to your friend or your colleagues, and they will see exactly the same thing, right? And that's the benefit of containers. Now, I'm going to go back to the presentation, and then we're going to discuss how these containers are useful, but when there are too many containers, what do we do? So so if you're doing the material, I'm asking you to pause it for a second. We're going to do the lecture, and then you can continue. But I think it's important that you listen to the next part. So generally, what we have is, okay. So generally, what we have is we want to deploy applications inside servers or virtual machines or Raspberry Pis. I'm not judging. You can do anything you want. But generally, what we do is we provision the environment, right? So we install the runtimes, we install Java, and then we place the application inside. Now, if you have to do that just for one application, that's OK. But what if your server needs like several different binaries, several different applications? You need to spend the entire day just clicking and installing stuff. .NET framework, Java, whatever you have, right? But I don't know if you noticed, with Docker, we just need to do a Docker run, right? It could be Ruby, it could be Java, it could be Node.js. It's just a Docker run. So in reality, all the applications that you build, they look the same. As long as you can do Docker run, you can deploy them inside your server, right? And that's the beauty of Docker containers. That's why they are so popular, right? And many people are using it. So easy to share, so easy to run, okay? So we have our application, right? And we just wrapped that inside the Docker container, and we wrapped the database inside a Docker container as well. And then we connected those two together. So ideally, I want the same inside the server as well. However, when I run this application at scale, I think there are a couple of challenges, right? I've done Docker run for MongoDB and Docker run for the application, but what if my note-taking application with a cat is extremely popular? Are you ready to go in and type Docker run 20 times? I mean, maybe you can, but what if it's extremely popular, right? Are you going to get SSH, are you going to get inside your virtual machine, inside your server, and type Docker run 100 times, 1,000 times? That's a little bit tricky. The other things that is tricky is that sometimes we have so many Docker images, right? That we've got more than one single machine. So we need to go inside that machine and launch a container, exit, go in the other one, launch a container. It's very, very inconvenient. Well, it's inconvenient if you've got 3 of them. What if you've got like hundreds of thousands of servers, right? Like Google scale, or even if it's not Google scale, right? You might do like machine learning, and you need like 100 machines. That's a lot of stuff. So is this Docker useful at all? It's rubbish again? What should we do? Well, I think everything was simple when we had a single machine. Everything is simple because everything can be done locally, but it becomes complex when we have more than one machine. Now, again, we couldn't blame Docker for that, but the reality is that this sort of problem I solved by another set of tools called container orchestrators, okay? And there are several of them, and you might have heard of some of them, like Mesos, which has been renamed, by the way, Nomad, or if you're working with Amazon Web Services, you might have heard of ECS, the Elastic Container Service. So those are orchestrators, right? Like Kubernetes. The only thing is that it's not a fair fight, okay? So Kubernetes is by far the most popular container orchestrator. So what is this Kubernetes and how does it work? Or do you want to cover Nomad today?
Is there a reason why Kubernetes is more popular?
I think, let me finish the presentation and then I'll address your question, okay? So Kubernetes, so what it is and how does it work? So first of all, the reason why Kubernetes is so popular is because what we basically do is we just have a collection of machines and we just install the master node, make the other computer join inside the cluster, and they will just behave as a single unit. Okay, so that's really powerful. So when we deploy something, we just deploy that something inside a single unit, which is much easy to reason about. The reality is that Kubernetes will take over and then we'll just deploy inside the servers, right? By judging where it should go, where these applications should go, and how many of them, right? So what we're going to do today is we're actually going to try and deploy this application. So in this case, I've got a red page, but the reality is that we're going to build, we're going to deploy our own application, our note-taking application inside Kubernetes. So what we're going to do is, generally we want our users to go to the application. So when we have 2 instances of it, how we distribute the traffic to the 2 instances, if you were to do it right now without Kubernetes, what would you use to distribute the load? I would use a load balancer, right? And that's what we do in Kubernetes as well. The other things that sometimes happen is you might have more than one application, right? You might do microservices. So how do we distribute the traffic between the 2 applications? How do we route the traffic between the 2? Any idea?
Gateways?
Sort of a gateway, more like a router, right? We need something to distribute this load. If this is for app A, we're going to send it to the left. If this is for app B, we're going to send it to the right. Okay? So in Kubernetes, we have exactly the same component. But in Kubernetes, we like everything to have a different name. Okay? Because we want to feel special. Reality. Okay? So instead of calling load balancer, we call them services. Instead of calling load balancer, the external load balancer, the black bar, then we call it an ingress. Okay? And then why stopping there? Right? I mean, we can call with different names everything. And this is exactly what we do. We call the application pods, right? That's how it works. So these are the basic components in Kubernetes. So we've got pods, services, and ingress. But there is another one which, it's not in the picture, which is extremely important. This is what you're going to use right now to deploy your application. And that's called a deployment. So a deployment is basically a recipe to create instances of your application. Okay? So you say, the application looks like this, and then you're going to say how many copies. The deployment is in charge of creating those copies and then watching over them. Okay? So if you say there are 5 and one is deleted, then Kubernetes will bring that up. Okay? So the deployment will do the job of just watching over and make sure that they always work. Now, everything you see here is what we're going to do right now. We're going to deploy our application, then we're going to use a deployment and a service to expose it, and then just have our application inside a cluster, and maybe scale it and see if deleting one pod is going to recreate it. To do that, we need the cluster. Okay, so Kubernetes is basically just a container orchestrator. So we need a Kubernetes. So where I go and buy one. It turns out that you install Minikube, and Minikube is a local cluster, okay? And the reason why we find it useful is because it's very easy to start, and it's very easy when something goes wrong, you can just delete it and restart it, okay? Generally, we don't have the same sort of luxury when we deploy things in the cloud. So you cannot just simply go and delete the dev server, right, or the dev cluster. I mean, you can, but the consequences are a little bit different. So what we do is we have a local cluster. You're going to start Minikube, okay? And then we've got something else called kubectl, which is a command line tool, which is going to send the commands to the cluster. In the same way you had the Docker CLI sending the commands to the daemon, then we have kubectl sending the commands to the cluster. So we're going to use kubectl to send the deployment and then to create this cluster. So that's how it works. Now, it would be too easy to just send commands. So in Kubernetes, instead of sending commands, we send descriptions of what we want. Okay? And these descriptions are done through a language called YAML, which is just a configuration language, right? And we say what we want, how many copies, and then all this sort of configuration. So generally, the question I get at this point is, do I need to memorize all of this? Yes. No, I'm joking. You don't have to. Okay, this is very complex. I'm not expecting you to remember any of this. I mean, maybe a little bit, just this one maybe, just the image, right? What kind of things I want to deploy. But everything else, with time, you understand how it works. So don't memorize this, just have a look at it and pay attention to the last line. That's it. The language is called YAML, and it's basically just a superset of JSON. So if you want to, we generally don't do this, but if you want to, you can also write the same definition as a JSON payload. It's much harder to write because you need all the quotes and all the curly braces, but if you like hard things, you can do that as well. Okay? So when you send that request, it's going to get to Kubernetes. Kubernetes will eventually create these resources on your behalf. So now this is exactly what I want you to do in the next session, right? I want you package the application as a container. I want you to deploy that container inside the cluster and see the same application deployed inside the cluster. So you're going to create a local cluster with Minikube. So Minikube start is the command, and then you're going to deploy the container you just created inside the cluster. You will also need MongoDB for that. And make sure that the application works. Okay, so that's the job. As usual, you find all of the steps in the documentation. Okay, so you can just follow along. But I'm planning to show you what it should look like in a second. So as usual, the section we're looking at the moment is called deploying to Kubernetes. Okay, so let me show you what it should look like at the end. Okay, so you're going to start the cluster with Minikube start. So mine is already started, okay? So it's going to be, hopefully it's already started. Maybe it's not. So you're going to see the cluster coming up. I thought it was already started. Okay, done. That's the end. So at that point, the cluster is running. How do I know that? I usually type Minikube status. Okay, it's telling me it's running. Job done. How do I check if it is really running? If I don't believe in the Minikube status, I type kubectl version. kubectl version is telling me a lot of things. But one thing it is saying is the client version and then the server version. So the client version I get always, and the server version is the current server I'm connected to. So it is actually working for me. The next step is to go in the right folder. And then define what I want to deploy. I do that by defining this YAML file, so this configuration. So the configuration usually comes, you can have multiple files, or in this case, I can have a single file and then have these sort of 3 dashes to delimit the resources. So the first resource I've got is the service. We talked about the service as just a load balancer. And then the other one is the deployment. So in the deployment, we say what the template, which is basically what this resource should look like when we create instances, okay? And then we've got the same sort of configuration variable that we had when we had containers, and then a container port. So I think some of this might be familiar. Some of it will be quite complicated, like this part, for example. So I think for the time being, we don't need to understand this to deploy to Kubernetes. So that's what we'll do. So when you have this description locally, the next step is to just submit that to the cluster. We use the apply command, and I'm going to deploy MongoDB, and I'm going to deploy the application, okay? And that is going to create the resources. How do I know that? I can do a kubectl get pods, and I can retrieve what kind of application were deployed, And I can also retrieve the services, so these sort of load balancers. And I can see that both of them are working. So how do I access that? I can do a minikube service, and then the name of the service. And I see the application up and running inside Kubernetes. And I can test it. Oh, okay. I'm not going to test the images. There we go, all up and running. So I want you to do the same. Start a cluster, write the definition, deploy, show me that it works. We'll be running around just helping you if you get stuck. Okay, so I know some of you are deploying to Kubernetes. Some of you managed to deploy, to get to the next part, to get the certificate, to pretty much done all of it. If you haven't, don't worry. It takes time and practice, okay? And if you are on Windows, it takes even more time and more practice, okay? So what I wanted to show you today before we close this session. So now I'm just going to do a quick. I'm going to point out the next 2 sessions that you can do at home if you, and to complete the material. So there are basically 3 things you can do. You can do and scale your deployments, right, and have more instances of the app, so you can handle more traffic. And then you can deploy the application inside AWS, right? So the same config file, the same YAML that you wrote today to deploy locally works inside AWS and works inside Azure and works inside Google Cloud, okay? And that's one of the reasons why we like Kubernetes, because we can use the same YAML files everywhere, okay? So I wanted to show you what it looks like. So when you go back and you do the material, you have an idea of what it should look like. So the first thing I want to discuss is scaling, right? So this is the kind of scenarios we have now. We have a single pod with a single deployment, and the traffic flows through it. But what you can do, you can use this deployment to create more instances of your app, right? You might say, I want 2. And then what the service is going to do, so this load balancer will basically just distribute the traffic from one, to one and the other, right? It's going to distribute the traffic evenly between the instances. However, is there anything wrong with this design? Is there anything that is not working when I use this application? Assuming that we have MongoDB running, okay. Is there anything wrong?
IP address?
Close. What about the images? Where are the images stored? I mean the images as in the cat picture, and then any other pictures you've used to test it.
So it's only on the first instance, not the other one.
Yeah. So I can see here an opinion. Anyone else in the middle or towards the end? What do you think is going to happen?
Like stateful, stateless.
It will be stay inside the pod.
So yeah. So if we upload the cat picture, right? Then that cat picture will be stored just on one of the 2 instances, and that's okay. But when you try to, when the traffic is routed to the other one, when you visit the page and you don't hit the same instance, right, you won't be able to see that image. The application is broken. So we don't want that to happen. So how do we fix this?
Put it outside, put it somewhere.
Put it somewhere else. Make it someone else's problem. I like that. So that's actually what we do. We call this kind of problem we kind of call these problems stateful problems, right? Or just stateful applications. And generally, when we deploy something in Kubernetes, we want it to be stateless, right? Why? Because we want to create n copies and not worry about picture of cats or anything else. So what do? Well, we have our application in Node.js or Java. We have a MongoDB. And generally, what we do is we upload these images into something like a block store, or like somewhere where we can put images. If you're familiar with AWS, that's usually S3. If you're in Azure, there is blob storage, GCP. Not sure what the name is, but everyone has got their own. Now, there are tools that also mimic AWS S3. So just a place where you can put these files. So a popular one is called Minio. And then Minio is just something that we can deploy inside the cluster. And it's basically going to give us an API where we can just call and upload files. Okay? And that's okay, because if the files are not on the file system anymore and they are in a central location, then we can have as many instances as we want of our application, and they're all going to retrieve these images from this sort of other database for files. Okay, so eventually what we want to end up is with, every time we store a node, that node goes inside MongoDB. Every time we upload an image, that image is stored in sort of a similar database, but just designed to store files, which in this case is called Minio. But it can be any other sort of service that does that. Okay, so that's basically what you're going to do in the next session. But some of you might have started this, but that's the idea. So you can try and refactor the app to make it stateless, and then try to scale it and see how it goes. So that's the next part. And there is another one which you might be tempted to do. Unfortunately, you will need a little bit of AWS credit for the last part, which is basically you deploy into the cloud, and then the same YAML file works locally and inside the cloud, and you have a fully functioning web application. Okay. So what we've done today, so this is the end, by the way. I don't have any, we're already over time a little bit, but we also started late. So what we've done today is we built the application, right? So if you use Node.js, it was easy. If you had Java, unfortunately, it was almost impossible because we found so many issues. Apologies for that. You package it as a Docker container, okay? So we understood how we create archives and how we can use them to pass them to our colleagues. And then the third thing that we did was to deploy these containers into Kubernetes. And then some of you managed to scale them, and some of you managed to see how everything works. Some of you managed to do all of the remaining parts. Good to you. And I've heard that someone got certificates as well. Very well done at the end. Yeah, I think you should try as well to deploy this application and get your own certificate. I think that's quite rewarding. So I'm going to say to all of you, well done for getting this far. And I think this slide is a little bit, broken. I'm not sure why. Yeah. So I just want to say thank you to everyone who helped, going around and fixing issue. And a special thanks to Madhvi as well. So she was, the first session, she managed to do all of it, and today she's here helping you out. So I hope that, so Kubernetes is extremely hard, okay, but you can do it, okay? And then the next time, you're going to be the one, standing here and explaining how these things work. I really do. I think, you should try. And we're going to run this session again, maybe. And then I want to see you, with me next time, helping others. Okay? So what's next? Practice makes perfect. So if you haven't finished the material, I think you should, right? It's very useful. And if you have any questions, just ping me. My name is Daniel. You can find me on pretty much everywhere. Twitter, LinkedIn, whatever. I'm not trying to hide. And the material is for you to have. So everything you see, all the PDFs you had today, it is going to stay free forever. Okay, you can use it and we update it. And then the other things we're doing, we're adding more languages as well. So maybe you don't know Java, maybe you know Python, maybe you do .NET. We're going to add those in as well. So this is not going to change. If you're interested in the rest of the content, we offer a discount, so you can get it today. It's 30% off, but you don't have to. The other material is going to stay free forever. So we are this company. We basically do training. You can see we just run in London. We ran one recently in Singapore, which was quite fun. And in general, we just travel around, and we do quite a lot of training in also kind of interesting places. That's what we like to do. So thank you very much for coming. And I hope I'm going to see you again on Thursday. So we are running the Kubernetes meetup. There are going to be 2 interesting talks. But I've got a surprise, and I'm running actually a quiz night on Thursday. So we're going to ask questions about Kubernetes, and there might be prizes. Okay? I want to make sure that everyone enjoys, so I'm not going to ask hard questions. I mean, maybe 1 or 2. But if you enjoy that kind of stuff, I hope I see you on Thursday. And that's pretty much it. If you like this sort of thing, please tell me how bad or good it was, so we can make it better for the next class that we run here in Singapore. So if you don't mind filling in this like 5 seconds feedback, please do. And thank you very much for having me.
All right, so that's